Rutherford's nuclear model of atom. By 1911, the components of the atom had been discovered. The atom consisted of subatomic particles called protons and electrons. However, it was not clear how these protons and electrons were arranged within the atom. J.J. Thomson suggested the plum pudding model. In this model, the electrons and protons are uniformly mixed throughout the atom. For checking the Thomson's model, Rutherford and his students went on to do a famous experiment which brought out new dimensions of atom and its structure. Rutherford tested Thomson's hypotheses by devising his gold foil experiment. Rutherford reasoned that if Thomson's model was correct, then the mass of the atom was spread out throughout the atom. Then, if he shot high-velocity alpha particles, helium nuclei, at an atom, then there would be very little to deflect the alpha particles. He decided to test this with a thin film of gold atoms. As expected, most alpha particles went right through the gold foil, but to his amazement, a few alpha particles rebounded almost directly backwards. These deflections were not consistent with Thomson's model. Rutherford was forced to discard the plum pudding model and reasoned that the only way the alpha particles could be deflected backwards was if most of the mass in an atom was concentrated in a nucleus. He made the conclusion that the atom is 99.99% empty space. The nucleus contains a positive charge and most of the mass of the atom. The nucleus is approximately 1,00,000 times smaller than the atom. He thus developed the planetary model of the atom, which put all the protons in the nucleus and the electrons orbited around the nucleus like planets around the sun.